We ended part 4 of this workshop series by taking a look at how life apparently works in this model of the holographic universe. Let's review that briefly. First, your infinite I creates you as a player to represent it in the human game. Second, your infinite I, and not you, decides on an experience it wants you, the player, to have, and writes the script for that experience by choosing the specific wave frequencies in the field that will create this holographic 3D total immersion movie. Third, your infinite I downloads the wave frequencies for this script to your brain, along with everything you as the player will need to have this experience, including the money and the support from other players as appropriate. We'll talk all about that in a few minutes. Fourth, if there are other players involved in your experience, their infinite I's download to their brains their own individual scripts and their parts to play in your movie that have been written or approved by your own infinite I. Fifth, each player has its own unique and individual experience as everyone acts out this movie, reading their scripts. Each player has total free will to react and respond to its own unique experience in any way it wants, and no reaction or response by any player is wrong or better than any other reaction or response. Wait a minute. Let's stop here. If you remember, Bashar said in part 3 of this workshop series that our job as players, what he called personality constructs, is to perceive the experiences our infinite I, what he called the higher self, creates for us.
It might surprise you to know, as personality constructs, as physical minds, you do not conceive of any ideas. What do I mean? The personality does not conceive of concepts. It perceives concepts. It does not conceive them. Here are the 3 levels. The higher self conceives. The physical brain receives. The personality mind perceives. That's all it does. One more time, because this is crucial to understand. You don't conceive of any ideas as a physical mind. That's not what the physical mind is designed to do. It cannot create ideas. It can only perceive the result of an idea from the higher self.
So it certainly seems that a lot of our reactions and responses to our experiences depend on how we perceive them, how accurate our perceptions are, and what might influence or interfere with those perceptions. Let's take a few minutes and look at our perceptions, and let's start by having some fun and watching some videos by Dr. Daniel Simons.
I'd like you to take a look around you. Take in all the sights, the sounds, if you're unlucky, the smells. You feel like you're seeing the world in all its completeness and detail. You feel like you're experiencing the world as it is. But that experience, as it turns out, is an illusion. What you actually experience is what your mind and your brain give you. It's an alternate reality. Take a look at this image. This is by Julian Beaver, who's a British artist. Now, this is an illusion. This is a nice painting of a swimming pool. It looks like it has depth. It looks like there's a woman sitting in the pool. It looks like Julian Beaver up on the upper right is dipping his foot into the pool. And as he's doing this, you feel like you're seeing the world as it is. But of course it's not. It's chalk art on a sidewalk. It just gives the impression of depth. And this is a double illusion, because as you're looking at this, you feel like, okay, yeah, I'm seeing a painting of chalk art on a sidewalk. But what you're actually seeing is a really weird view of a chalk painting on a sidewalk. You're seeing a chalk painting on a sidewalk from the one view that gives you the impression of depth, that gives you the impression that you're looking at a swimming pool. And from any other perspective, it looks much more like this. It's really substantially distorted. The key is that we feel that we're seeing it as it is, but we're actually not. Let me give you another example. This is from my colleague Bart Anderson. What you see here are two sets of chess pieces. The ones on the top look dark, the ones on the bottom look light. I'm sorry, the ones on the top look light, the ones on the bottom look dark. And you can't help but see them that way, even though that's not at all what you're actually seeing. Here's what you're actually seeing. I'm just removing the background. And when I remove the background, you can see that both sets of pieces are the same kind of mottled gray, and every piece on the top is exactly the same as the one directly below it. Now that you know that, of course, you'll be able to see them as they are when I show you the same image again, right? Nope. Once you go back to the background, you can't help but see it as it isn't. Your visual system is giving you the impression that you're seeing light pieces and dark pieces when you're actually seeing the same thing in both cases. What's happening here is that your visual system is taking into account not just the brightness of those individual pieces, but the brightness of the surfaces immediately around those pieces. And it takes that into account in a way that's actually really useful for us most of the time. It gives us the ability to see a piece of paper with black ink on it, the same inside in a dark room and outside in a really bright light. But it's not giving us the world exactly as it is. It's using a bag of tricks. It's using a set of shortcuts to give us the world as we need it. Now, what makes visual illusions like this so cool? There are two reasons. One is that it's surprising, but that's not terribly satisfying. The more interesting reason is that it's giving us the impression that we're seeing the world as it is, and it's violating that impression. It's breaking our intuition. It's forcing us to confront the fact that we aren't seeing the world as it actually is. Let me give you another example of this. This is from Bill Geisler and Jeffrey Perry. This is a nice picture of flowers, pleasant for today. I'm going to show you a bee, and I want you to follow that bee around this image with your eyes. So track the bee as it moves through the image. So it's just going to kind of wander around the image here, and you're able to follow it just fine. And eventually it's going to end up back where it started. And we're back. Okay, now I want to show you exactly the same sequence, except this time, instead of tracking that bee with your eyes, I want you to maintain your focus, maintain your gaze right on the bright yellow flower. And notice what happens to that flower as the bee gets farther and farther away. It gets blurrier and blurrier. That's exactly the same sequence. You're seeing exactly the same thing you did the first time, except that this time you probably noticed that it's getting blurry, whereas the first time you didn't notice that anything was changing about the image at all. Well, why is that? The reason is that you're actually only taking in detail from a tiny, tiny subset of your visual world at any instant. In fact, you're taking in detail from a subset about the size of that bee. Right? You're taking in, if you stick your arm out and put your thumb up, you're taking in high-resolution information only from the information about the width of your thumb. Beyond that, it becomes progressively blurrier, but we don't notice this at all. Why not? Well, we move our eyes 3 or 4 times a second when we're looking at the world. We don't realize we're doing that. And everywhere we look at that instant, we're seeing everything in detail. If something's in our periphery and it's potentially interesting, we look over there and we see it in detail. So we get the impression, the false impression, that we're seeing everything in detail. Let's take a look at this issue. We assume that everyone is seeing the world exactly as it is. And this has profound implications for how we think about the world around us. Despite differences in our knowledge and our beliefs and our expectations, we feel like we're seeing the same thing as everybody else. I've used visual illusions as a way of illustrating how we don't see the world exactly as it is, but these sorts of illusions are not just limited to our visual system. They're not just limited to our visual system, they also affect the way we think, the way we remember, the way we reason. We think we see more than we do. We think we see all of the detail around us. We don't. But we also think we remember more than we do and that we know more than we do. And these illusions lead to a really substantial problem. They lead us to think that everybody is seeing the same thing that we are, when in reality, two people looking at exactly the same world could be taking in different information at the same time. Now, what does that mean? It means that any time you have to communicate, any time you're trying to be a trainer or a CEO or a leader, or you're trying to lecture or teach, you have to take into account the fact that your knowledge and your experiences and what you see are going to be different from those of the people in your audience. All of advertising depends on exactly that principle. You have to know what your audience is going to see in the advertisement. Now, the problem is that we all share one thing. Even though we don't necessarily see the world the same, we all share one thing. We share this illusion that we see the world the same as everybody else. And only by testing your knowledge and testing what you're actually seeing, just like you do with a visual illusion, do you realize that you're not actually seeing the world as everybody else is. And in fact, we don't all see the same thing. Only by testing your knowledge can you see the world as it actually is.
Here are some important quotes from that video. The key is that we feel we are seeing the world as it is, but we're actually not. Our perception is not giving us the world exactly as it is. It's using a bag of tricks. It's using a set of shortcuts to give us the world as we need it. We assume that everyone is seeing the world exactly as it is, and this has profound implications for how we think about the world around us. Despite differences in our knowledge and our beliefs and expectations, we feel like we're seeing the same thing as everybody else. And in fact, we don't all see the same thing. Now, the problem is, even though we don't necessarily see the world the same, we all share one thing. We share this illusion that we see the world the same as everybody else. I use visual illusions as a way of illustrating that we don't see the world exactly as it is. Only by testing your knowledge and testing what you're actually seeing do you realize that you're not actually seeing the world as everybody else is. So let's take Dr. Simon's suggestion and test our perceptions to see how accurate they really are. Some of you may have seen these before. If so, just play along. Grab a piece of paper and something to write with, and number down the left-hand side from 1 to 13. Now, simply answer the questions, starting with number 1. Number 1, true or false? The red lines are all straight and parallel. Number 2, true or false? The green column is the largest of the 3 columns. Number 3, what color is the line making the circumference of the circle? Number 4, true or false? The red lines are all straight and parallel. Number 5, how many different colors do you see in this picture? Number 6, which dot in the middle is bigger, A or B? Number 7, true or false? Every line in this picture is straight and parallel. Number 8, true or false? Line A to B is longer than line B to C. Number 9, which box has the darkest gray dot in the middle? 1, 2, 3, 4, or 5? Number 10, true or false? The long straight lines are all parallel. Number 11, true or false? The straight vertical line in A is longer than the straight vertical line in B? Number 12. Do you see a young woman or an old hag? Number 13. Are you looking at the front or the back of this woman? Let's see how well you did, how good your perceptions are. Number 1 is true. The red lines are all straight and parallel. Number 2 is false. All 3 columns are the same size. The answer to number 3 is that there is no line making the circumference of the circle. It just appears that way. Number 4 is true. The red lines in the pictures are all straight and parallel. In number 5, there are 3 different colors: white, red, and green. The red is the same red throughout the picture, and the green is the same green throughout the picture. In number 6, both the dots in the middle of A and B are the same size. Number 7 is true. Every line in the picture is straight and parallel. Number 8 is false. The line from A to B is exactly the same length as the line from B to C. In number 9, all the gray dots in the middle are exactly the same shade of gray. Number 10 is true. The long straight lines are all parallel. Number 11 is false. Both straight vertical lines in A and B are exactly the same length. Number 12 is interesting because both a young woman and an old hag are there. Can you see both? Looking at the left side of the old hag's face, you can see her left eye, her nose, and her chin. Looking at the left side of the young girl's face from behind, you can see the tip of her nose, her left ear, and her chin. Number 13 is equally as interesting. You can see this woman from the front or the back. The best way is to look at her breast. If you see this woman from behind, that's her right breast, and her left knee is in front. If you see her from the front, that's her left breast, and her right knee is in front. If you have seen these illusions before and know the correct answers, or if you could figure them out, you still have to force your mind to overrule your brain, because, honestly, when you look at these illusions, our senses perceive them to be very different than what they actually are. This whole question of perception is a fascinating topic, and apparently very key to our job as a player. So we're going to watch 2 more videos with Dan Simons, who is a prominent experimental psychologist, cognitive scientist, and professor in the Department of Psychology and the Beckman Institute at the University of Illinois. Simons is most well known for his work on change blindness and inattentional blindness, 2 surprising examples of how people can be unaware of information right in front of their eyes. This next video is his most famous, and will test what your